Assalamualaikum warahmatullahi wabarakatuh. Today I will introduce you to chapter 6, which is developing fundamental PLC wiring diagrams and ladder. This chapter will cover electromagnetic control relays, contactor, motor starters, manual operated switches, mechanically operated switches, sensors, output control device, holding circuits, and how you can convert this relay schematic into the PLC ladder diagram. So the first part is a theory basically, and will explain to you the hardware of each of these type of the devices. And the second part, which is the holding circuit and converting relays schematic into PLC ladder, would be you will do the ladder diagram. So we will go very fast on the theory, and you can read on your own, and you can find more information from the Google. You can Google out so many information if you want to know more. So I just give some of it. So the learning outcome of this chapter would be explain the function of these relays, contactors, motor starters, and you're able to diagnose switches or sensors which commonly found in PLC installation, where you know whether the switch and sensors is on or off state, and you're able to analyze the operation of this electromagnetic latching relay and the PLC program latch and latch instruction, or in our case we use set or reset. And finally, you can compile this ladder diagram, the relay ladder diagram, into the PLC ladder logic diagram using the Lexim. Okay, first is electromagnetic control relay. So how it works? Okay, PLC was designed to replace the control relays that made the logic decision. Okay, whether it's the contact is open or the contact is closed. One is open, there's no connection between the input and the coil. Okay, so that is how it's work. And this is when the relay is de-energized. Okay, so this is the switch is open here, and this is when it is energized, when the switch is closed. So these are the common symbol that we use for normally open and normally closed. What it means by this, normally open means that it's open. Okay, it's open when the coil is de-energized. Okay, when you don't do anything, so the contact is open, and only will close when you energize, like say if you press the start button and so on. Okay, so these are the symbol that we can use. Okay, this is the coil for the motor. Okay, use M, or control relay, you can use CR. So these are the common symbol that you can find when you find information from the Google or from other sources. So this is the example when this is the example of to control two pilot light. Okay, so we have two relay diagram. One is when it de-energized, and the other one is when it is energized. Okay, so when it is in de-energized state, so the switch is open, and when it at energized state, the switch is closed. So this is the equivalent of the PLC ladder diagram. So the address here is normally used for Allen Bradley model. However, for our case, we use in our lab, so we can use this internal relay. You can replace with this address. Okay, and this button you can replace with start button. Okay, and this is the one that I simulate using the LetSim. So you can play with this LetSim later, so you can see the output, how it works. Secondly is contactors. Okay, this contactors is a special type of relay where we design these for heavy power load that are beyond the capability of normal control relay. Okay, so of course PLC is used in conjunction with this contactor to switch the power on and off to a pump. Okay, so we cannot connect the pump direct to the PLC because it needs very high power. So that's why we need this contactor, so that we can have a proper wiring of the system. Next is motor starter. Okay, so motor starter is made up of a contactor with an overload relay. So we really need to put this because if to avoid this overload, so this relay will switch off when there is an overload happen. This is how we wiring the three-phase magnetic motor starter. Later we will draw the ladder diagram. Next is manual operated switches. Okay, so makes a circuit when it press, okay, when it press and returns to its open position when the button is released, like we use in our lab. When you press start button at normally open, and when you release the button, and it also will release. This is where the condition for the normally close. So at the start it already closed, and when you press it, you will make the circuit de-energize. Next is the selector. You also can see it in our lab. Okay, we have two selector, which is auto mode and manual mode. There are other type of selector. For instance, they have in this position 3 selector. So you can find other types of selector. Also, we have dual inline package switches. There are small switches which is assembly for mounting on printed circuit board. So it's very small in size. Next is mechanically operated switches. Okay, by its name, it is controlled automatically by factors of either pressure, position, or temperature. So this switch will be energized by this factor. So this limit switch is designed to operate only when we have a predetermined limit is reached. Okay, we have a certain limit that we have set for, and when it reaches to that limit, then only the actuator will actuate by contact with an object such as a cam, for instance. Okay, so the other one is temperature switch or thermostat. I think you have familiar with this. Okay, so these temperature switches also open and close when the designated temperature is reached. So, for instance, if you have we set our fridge, for instance, to be stopped at certain temperature, so it will stop the operation when it reaches that temperature. And next is pressure switches, which are used to control the pressure of liquid or gases. Okay, they are designed again the same open and close contact, So when a specified pressure is reached, so it can be either pneumatically and also hydraulically. So for small application, we can use air, and for heavy application, normally we use hydraulic. Level switches, normally we use to sense the level of liquid inside a tank. So this is a lot being used in process industry where they want to identify what are the current level of the liquid inside the tank. So they use this float switch, which is weighted so that as the liquid rises, the switch also floats and turns up and down. It depends on the level. Part of this chapter, so I will stop here. I hope you can keep viewing this video to help you to understand. Thank you very much. Assalamualaikum.